Hi, this is Mrs. Kidman, and in this video, we're going to be discussing how we can prove that the interior angles of a triangle add up to 180 degrees. So what we're going to do is we're going to start, and in this case, they gave us that we start with line C being parallel to line AB. Now, if you just had a triangle, it is easy to just say that we want to construct line C and line AB such that C and AB are parallel, and line C goes through the point C of our triangle, and line AB goes to the points A and B of our triangle. So you can kind of do it either way. I like to just start with those lines included there. So that's what we're given, that these two are parallel to each other. And that's super important because guess what that means? That this line AC, this line segment AC, it acts like a transversal. Similarly, this line CB, this line segment CB also acts like a transversal. Because we have these two separate transversals, we can use some of our properties or our theorems where two parallel lines are cut by a transversal in order to prove this. So we have those two things. Let's start by creating our two-column proof. Now here's kind of what I'm thinking. We've got our statement. We've got our reason. Now let's go back to our triangle over here. So we've got our, I'm going to draw a new picture so I can draw all over it. So here we are with our triangle. We've got our two parallel lines. Now, if this is one of our transversals here, what I want you to think about is this idea that this, according to the alternate interior angles theorem, that this angle is the same as this angle. Okay, hear me out there. So there's that one. Similarly, we have this line right here that also acts as a transversal. And that transversal says that this angle is going to be the same as this angle. Does it not? Alternate interior angles theorem. Lastly, it tells us that, let me pick a new color here, blue. This dark blue angle here, plus the purple one plus the orange one equals 180. Why? Well, they're a linear pair. So if the purple one plus the navy blue one plus the orange one equal 180, and the purple one's the same as the purple one in the bottom corner, and the orange one's the same as the orange one in the bottom corner, then doesn't that mean that all those angles are also 180 because they're equal? Well, that's what we're trying to prove. So we can logically see that this will work. In order to make it a proof, we need to attach those reasons behind everything that we do. So let's first start with what we're given, that line C is parallel to line AB, and that was given to us. Okay, so with that idea that that's given to us, the next place that we want to start is we know that line B is not line AC, that line segment that creates a side of our triangle acts like a transversal. Because of that, what I want to do is I want to talk about these purple angles and these orange angles. The way I'm going to do that is I'm going to add in two extra points here to my picture. I'm going to add in point P and point Q. That way I have this reference point that I can use there. Because on the other angles, we've got like angle CBA that we can talk about, those inside angles based on the triangle. But to get these exterior angles here, we're going to need some other points. So we are going to have points A, point P and point Q are on line C. Now, what's the reason that I can put those on there? Well, that's the definition of a line. A line is the shortest distance between 2 points. So if 2 points are on that line, it's the shortest distance between those 2 points. So any points can be on that line because a line is constructed of infinitely many points. Each point could be representing every real number that exists, is how we look at it. So P and Q are on line C based on the definition of a line. So with that, we know that angle P, this is C, this is A, this is B. The angle PCA is going to be congruent to angle CAB. And how do we know that those are congruent? Well, that's by that alternate interior angle theorem. And that's the one we proved in the previous video, that those two things are congruent. Similarly, we know that angle, I'm going to use a different color here, QCB. Oh, let's go back to black. Angle QCB is going to be congruent to angle CBA. And the reason why those are congruent is the same thing. They are alternate interior angles. Okay, and so that's by that alternate interior angle theorem. Then, right before we started this proof, we talked about how this line right here makes those three angles all a linear pair, right? So what this means here is we have the measure of angle PCA plus the measure of angle ACB plus the measure of angle QCB equals 180. Why? Well, because they're a linear pair. Now, how does that idea of those being a linear pair helps us? Well, by the definition of congruence, which we know, we have that. So by the definition, oh, not by the definition of congruence. I want to write that over here. By the definition of congruence, we know that the measure of angle PCA equals the measure of angle CAB. Also, the measure of angle QCB is equal to the measure of angle CBA. Okay, so we know that those are all equal to each other by the definition of congruence. Therefore, if they're equal to each other, let's extend our thing here, then that means that the measure of angle PCA is the same thing as CAB plus the measure of angle ACB plus the measure of angle CBA equals 180. Now, why can we substitute those in? Well, that's because of the substitution property of equality. Okay, so then that's so close to what we have originally up here. Now, when it comes to talking about our angles, a really important thing to keep in mind is when we're talking about angles, the way that we label angles is dependent on what point we start at with that point in the middle. So that actually means that angle CAB is the same thing as, or angle ABC is the same thing as angle CBA. And that's the only one that doesn't match what we have up here, in addition to this ACB. And angle ACB is the same thing as angle BCA. They're just reversed in the point order that we list them. So therefore, by the definition of an angle, we know that the measure of angle CAB plus the measure of angle BCA plus the measure of angle ABC equals 180. Now, the very last thing that we need to keep in mind is that we can rearrange this order as we need to. And the reason why we can rearrange their order is based on the idea of that symmetric property of equality or that reflexive property of equality, or similarly just addition. The fact that addition is closed means that it can be added to, meaning that we can add them in whatever order, and it doesn't matter. Therefore, based on the definition of addition, we have exactly what we have up there, that the measure of angle ABC plus the measure of angle BCA plus the measure of angle CAB equals 180 degrees. And therefore, we have proven that the interior angles of a triangle all add up to 180. Now, sometimes we will say, instead of going through all these steps of rearranging those, we'll say, we'll reference it without loss of generality. So we're talking about this specific thing, but in this case, without loss of generality, we've shown that these angles add up. Therefore, it's always going to work there. And so that is how you prove that the interior angles of a triangle add up to 180. It's always going to work because if we construct those parallel lines, we use that alternate interior angle theorem to prove that. So if you have any questions, feel free to reach out, but that is how you prove that the interior angles of a triangle equal 180.